We have looked at the two-pointer technique for three problems. The first problem was this problem of finding the pair sum, on a sorted list. So there the pointers pointed on the same list, right and left pointer, and they kind of started moving towards each other. Like I'm showing this in this illustration as well as this. We spoke about this in detail. Next, we looked at the problem of merging two sorted lists. In this case, the two pointers pointed on two different objects, and in fact, as this illustration says, the pointers moved in the same direction. But again, we had a very clear rule on how do the pointers move. So now if I were to reflect on these two examples, in both the cases, we were dealing with lists that were sorted, but the pointer movement was different. As we spoke in the pair sum problem, pointers pointed to the same object. In the merge list problem, pointers pointed to different objects, different lists. Pointers moved in opposite direction, pointers moved in the same direction. And then we went ahead and looked at the problem where the list was not sorted. That was the carpet area problem. In this case, the pointers pointed to the same list. The pointers moved towards each other. The intent with which they moved was to maximize the area that is bounded by two lines. And the way we did it was to say that, okay, look, the pointer that's pointing to the shorter line must move inward. In all the cases, in all three cases, we realized that the two-pointer technique helped us bring down the complexity from a quadratic for a, let's say, which is square complexity, in the naive case, to a linear complexity with the two-pointer technique. So with this, we are, ready to summarize the key ideas from the two-pointer technique. Basically, the idea is that we are using two pointers to move independently according to a certain criteria. Now, this criteria has to be super, super clear because only then the code becomes clear. Also, the pointers, as I said, are moving independently. The pointers need not start from the extreme ends. We already seen that. The pointers can be pointing to two different lists and strings, as we have also seen. The data itself need not be sorted, but no matter what, we need a clear criteria to decide the strategy to move the pointers. Think about it. This is what we have been driving through the three examples that we have looked at. In all cases, the idea is to reduce the complexity down to linear scaling. We will see a special case of the two-pointer technique called the sliding window technique in the subsequent lesson. Basically, here in the two-pointer technique, we are interested in the exact values that the pointers are pointing at. In the sliding window technique, we are interested in looking at all the values that lie between the two pointers locations. So it's kind of like a window or a sub-array of data that we'll be looking at, unlike this situation where we're looking at just those two extreme values. So that is for another lesson, but I hope you found this discussion interesting. Do think through the three examples and practice, because ultimately practice is what brings us mastery. We understand how to apply these ideas to different problems by doing more and more practice. As always, happy to discuss. And do look at our website www.ybyte.in. We have a lot of material through which new programmers can learn Python, logic, algorithms, and forever enjoy coding. Take care. Thank you so much. Bye bye.